All right, so now we're going to take the same information that we had in example 1 and create a hypothesis test. And we're going to test at the 1% level of significance whether the data provides sufficient evidence to conclude that company 1 has a higher mean satisfaction rating than company 2. We're going to use the critical value approach. All right, so let's start with our null H0. And in this case, we're going to have that our mu1 minus mu2, I'm just going to do it like this rather than trying to spend too much time looking up the symbols for mu. All right, so mu1 minus 2. If there isn't a difference, which is what we're going to assume for the null, then that means our difference is 0. There's no, one company's not better than the other. There's no difference between them. All right, on the other hand, what we want to show with our alternate is that mu1 minus mu2 is going to lead to some positive answer because mu1 has a higher mean satisfaction rating than mu2, which means when we subtract those two, there should be a number that's bigger than 0. All right, so we've got our hypothesis set up. Let's go ahead and look up our critical value for our test statistic. Now let's notice this is a right-tailed test, so we're not going to have the same z of alpha that we had up here. So in this instance, we're going to look up 0.01. Now realize when we go to our stat track, 0.01 is going to be the area to the right. And on our stat track, it looks up areas to the left. So we really want 1 minus 0.01. We need to put 0.99 into stat track to get the proper test statistic. All right, so our test statistic Z will be whatever we get when we look this up. So let's go to StatTrak and put in 0.99. All right, so I'll take out what I had before, especially right there. And let's put 0.99 in the box. And it tells us it's 2.326. 2.326. All right, so recall, now we're going to do, I'm sorry, this is our critical number and not our test statistic. Critical value. Now we're going to do our test statistic, and if that test statistic falls to the right of 2.326, since it's a right-tailed test, then it would be in the rejection region and we would reject the null hypothesis. All right, so let's do that calculation. All right, now our calculation now is a little bit different. Let me just remind you what that thing looks like. Here it is from our book. Okay, ugly looking thing, but notice that we've already done this top part right here. We've done the x1 bar minus x2 bar when we did example 1. So let's go ahead in that part and put that in. D sub 0 is really what was in our null hypothesis, and we have 0 for our null hypothesis. So that part is not going to make a huge difference. And then we did do this step by step in our example 1. This part right here that is the square root was actually in our confidence interval as well. And you notice I did that step by step so we can go back and get that value without having to redo it. So let's go back here. So we're going to have our x bar 1 minus our x bar 2, if we look up top, was 0.27. So it's 0.27 minus 0 for our null hypothesis right there, divided by that huge, horrible looking square root of s1 squared divided by n1 plus s2 squared divided by n2. We've got that right here. And notice that answer. Oh, we don't quite have it. We have the square root of 0.002257. So let's just put that down there then. Almost got that whole thing. think I wrote that correctly. Let me just double check it. Yeah. All right. So now let's do this calculation. So we're going to have 0.27 on top. And I'll go ahead and put the square root of 0.002557 into my calculator. And that ends up being 0.050567. And then let's do this final division to get our test statistic. And we will end up getting, if we round to 2 decimal places, 5.34. All right, now, you may remember when we look things like this up on the table, this is off the table, all right? And pretty much when things are off the table in the direction that we're looking for, we can guess that they are going to be in our rejection region. But here, let's notice our critical value was 2.326. I said earlier that if it was to the right of 2.326, it's in our rejection region. So certainly 5.34 is to the right of 2.326. And so that means it's in the rejection region. We're going to reject the null hypothesis. All right, so let's make our final statement. There is significant evidence, and we'll state our alpha here. Alpha equals 0.01 to reject the null hypothesis. Company 1 has a higher mean satisfaction rating than Company 2. And there we have it.